Hello everyone and welcome to today's online class. We are going to study about few of the questions from the chapter known as hydrogen. This chapter is comparatively very easy to do. That's why a lot of explanation from the side of us teacher is not required. So we are today going to study few of the important questions from this chapter, and I will advise you guys to go through this chapter and try to study it. This is not a very hard chapter to do. We all know that the atomic formula of hydrogen is this, and electronic configuration is 1:1. In the middle there is a nucleus comprising only proton, and in the extra nuclear part only one electron is revolving. This is the atomic structure of an hydrogen atom. There are three isotopes of hydrogen that exist in nature. Protium, number of proton in protium is 1, number of electron is 1, and number of neutron is 0. The second isotope of hydrogen is deuterium. H21, number of proton is 1, number of electron is 1, and number of neutron is also 1. The third isotope is tritium. H31, number of proton is 1, number of electron is 1, and number of neutron is 2. Hence the mass ratio is found to be 1:2:3. Now, when hydrogen form compounds, it compounds in the form of H plus ion, that is proton in the form of proton, or H minus ion in the form of hydride. When hydrogen is attached with a more electronegative element, it form the compound in the form of proton H plus. When it is attached with a less electronegative element, it combines in the form of hydride H minus. Like, for example, HF, hydrogen in HF is plus 1, and hydrogen is BH3 stays in the form of minus 1. As fluorine is more electronegative, that's why hydrogen in HF is plus 1, and as boron is less electronegative than hydrogen, it combines with boron, hydrogen combines with boron in the form of minus 1. Apart from these examples of compound of hydrogen, there are lots of several well-known compounds. Two of the most common one is H2O, water, and H2O2, hydrogen peroxide. We already has discussed about the structure of water molecule. That's why we're not going to deal with this portion in this chapter. But the structure of H2O2 molecule, the structure of hydrogen peroxide, we are now going to study that. The structure of hydrogen peroxide depend on the state of the hydrogen peroxide molecule. If the hydrogen peroxide molecule is in gaseous state, then the structure of the molecule will be like this. In this, the oxygen-oxygen bond length is found to be 1.47 angstrom, and the oxygen hydrogen bond length is found to be 0.95 angstrom. The bond angle between oxygen and hydrogen is 94.8 degree, and the angle between the two plane which consist the two oxygen hydrogen, the angle between that is 101.5 degree. Now this entire structure of hydrogen is depend on, and the parameters of these structures are in when the H2O2 molecule in gaseous state. But when H2O2 molecule is in solid state, the structure, the parameter of the structure is found to be a little different. The oxygen-oxygen bond length is almost similar, 1.48 angstrom. The oxygen hydrogen bond length is little bit higher but almost similar, 0.98 angstrom, but the angle here is quite different. That is, the angle between oxygen and hydrogen is found to be 101 degree 9 101.9 degree, and whereas the dihedral angle between the planes, between the two plane which consist the two oxygen hydrogen bond, is almost perpendicular, 90.2 degree. This entire structure is when the H2O2 molecule is found to be in solid state. This entire structure is known as open book structure. And thus, the first question regarding this chapter, from this chapter, is compare the structures of H2O and H2O2 molecules. Now in H2O molecule, oxygen atom is sp3 hybridized. There are two oxygen hydrogen bonds present, which are sigma bond, and this sigma bond is formed by the sp3 hybridized orbital of oxygen by combining the sp3 hybridized orbital of oxygen with the s orbital of hydrogen. The oxygen hydrogen bond angle in water found to be 104.5 degree, which is far less compared to the, which is comparatively less than the actual tetrahedral angle 109 degree 28 minutes. This reduction in angle is due to the lone pair repulsion that is coming from the two lone pairs on oxygen atom, making the bond reduced in magnitude. Thus, this shape has deviated from the actual tetrahedral shape, and the shape is called thus bend shape. That is quite different in H2O2. In H2O2, two oxygen atoms both have sp3 hybridization. There are two types of sigma bond. One is oxygen and oxygen sigma bond. sp3 hybrid orbital of one oxygen combined with sp3 hybrid orbital of another oxygen and form this sigma bond. And there are two oxygen hydrogen bond, which is also sigma bonds. This sigma bond is formed similarly like in H2O, water molecule, sp3 hybridized orbital of oxygen, and combine this sp3 hybridized orbital of oxygen with the s orbital of hydrogen. This bond, these two bond in water, oxygen hydrogen bonds in water, both of these bonds in water are in the same plane. That is quite different for H2O2 molecule. The two OH bonds are not in the same plane, creating the dihedral angle of 101.5 degree in the gaseous state and almost 90 degree in solid state. And thus the shape of this becomes the open book shape. These are the few of structural differences that can be observed between H2O water molecule and H2O2 hydrogen peroxide molecule. This next question is, Explain the thermal stability of H2O2 is very low. The thermal stability of H2O2 is very low because the oxygen-oxygen bond dissociation energy is only around 35 kilocalorie per mole. That is, the bond is very weak. Hence, H2O2 easily dissociates and gives active oxygen and acts as a very good oxidizing agent. Water is classified as hard water, and soft water. Hard waters are those waters which does not form lather with water, with soap. In fact, it form insoluble scum with soap. Example: river water, sea water, spring water, well water, tap water, etc. These are hard water, examples of hard water. Then, what is the definition of soft water? The opposite of the hard water, that water which readily form lather with soap. Example: distilled water. Now, the hardness of natural water is due to the presence of soluble salts like bicarbonates, chlorides, sulfates, etc. Now there are various methods by which this hardness of water can be removed. One of them are temporary removal of hardness. This temporary removal of hardness can be done by boiling the water, normal water. When you boil normal water, the carbonates of calcium and magnesium that are present is converted into, decomposed into the bicarbonates of calcium and magnesium decomposes to magnesium carbonate and precipitate out of the water medium, and carbon dioxide evaporated out of the water system, and thus the bicarbonates can be boiled out. But the permanent to remove the hardness of water, there is another process known as permanent removal of hardness. Permanent removal of hardness, permanent removal can be done in very different methods. I would suggest you guys to go through those methods and study them, because these methods are normal metallurgic methods by which you can do this permanent removal. Not very difficult to understand. Few of them do comes into question, but not the entire thing is into the syllabus right now due to some deletion that happened this year. So these are the most of the chapters, important portion that we need to cover up before ending today's class. These are the portion that was required me from the teacher side for you guys to for us to explain you. Very easy chapter. Go through this chapter, go through the questions that do comes from these chapters and study them. Not a hard chapter to do. These are the few of the important questions that we have done today. Okay, see you on the next class.